Hey guys, we are going to start Unit 1, 8.2a today, Monday the 24th, and it's about the real number system, so we won't take too long on this because you already know this stuff. 8.2a, we're going to extend the previous knowledge of sets and subsets using a visual representation to describe relationships between sets of real numbers. So basically on the STAR test, they want to know if you can distinguish between the sets and subsets of real numbers. Not so much as to what are those numbers, but can you understand the sets and the subsets of the numbers? Here's our essential questions. They want to talk about, once again, the different sets and subsets of the numbers, and that's all that is. We're not going to read through those. If you want to pause the video and read them, please do. In Canvas, this is where you're going to find your instructions. Everything in the lesson is on the lesson page. So right here, if you see a link, you need to click that because that's going to be your notes. You can either print the page out, you can copy it to your Google Drive, you can download it and copy it to your Google Drive, you can take a picture of it and put that in your Google Drive, or you can just copy the notes on paper. Those are the 4 ways you can get the notes. And when you open that page, you're going to see this is the first part of the notes. And this is the most important part because they want to know if you can tell the difference between sets and subsets. So this is called a Venn diagram. Okay, this is a Venn diagram, and it shows us that all the numbers inside the big circle are real numbers. And then this section over here is irrational numbers. But that section over there is not part of this section because it doesn't touch each other. Okay, so irrationals have their own numbers and rational numbers have their own numbers. Inside the rational numbers, you'll see the integers, the whole numbers, and then the very last one is the natural numbers. Sometimes they call this one the counting numbers. So these are your 4 sections. We have one side that has almost all the numbers, and then the weird numbers are over here. And we're going to get into that in just a minute. If you go down on your slides, well, you're watching the video. So the next slide it's going to describe the numbers that we just saw above. And let's go over this. So we have the real numbers here. This is our real numbers. Let's see if I can get a highlighter here. And I'm going to make it yellow. There. So the first section is the real numbers. And that is all the numbers. It's all the rational and all the irrational numbers. It's every point on the number line. It's everything, all numbers. The next one is the one on the right, the section on the right. That's your irrational numbers. That's weird numbers. Those numbers they include non-terminating, and terminating means doesn't end. Okay, so it never ends. That are numbers that never end. For instance, like pi. Pi never ends. That one never stops. 3.14, and then numbers go on forever. Or just other decimals that they don't repeat. Okay? Rational numbers are all, okay, that's irrational. I'm going to do the rational numbers starting from the bottom. The small section inside is your counting numbers or your natural numbers. That's 1, 2, 3, all the way up. There's no zero, no fractions, no decimals, no negatives. The next step is the whole numbers, which is all the counting numbers plus zero. So you have all the same numbers as the natural numbers plus the number zero. The next one is the integers. And that is all the counting numbers, all the whole numbers, and all the negative numbers. So we have all the negative numbers. They're negative whole numbers, so no fractions or decimals. Negative whole numbers, zero, and then all the whole numbers. Rational numbers are everything else. They include anything you can write a fraction for, like 3/4. That would be, if you turn that into a decimal, that would be 0.75. So it ends. If the decimal repeats, let's say you have 6.12121212 forever and ever, that would be a rational number because the decimal repeats. I think that's about it. I'm going to speed this up so this video isn't so long. So let's fill in a few of these. Rational numbers. Let's see if we can find some examples for some rational numbers. And I'm just going to put a text box in here and I'm going to write them out for us. Here's rational numbers. And they would be like 0.37 would work. 0.75, like I said. Negative 2/3 would be a rational number. 0.31. 31. Let's say it just keeps going on and on forever. That would be one. And let's see another one. 25%. Because you could turn that into a decimal and that would be 0.25. Now let's look at some integers. Integers would be, let's see. Well, we know -3 would be 1. We know -18 would be 1. We also know 0 would be 1. We know the number 1 and the number 3. And sometimes they might write it weird, like -10 divided by 2. -10/2. Because that would equal, what would that equal? -10 divided by 2 would be -5. So sometimes if you see a fraction or you see a percent, you need to convert it. You need to divide the fractions and convert the decimals so you can see what the number really is. Now let's do some whole numbers. Those are pretty easy. They would consist of, all the 0 plus all the counting numbers or the natural numbers. So we know 0, 1, 2, we know 0, 1, 2, and 3 would be numbers. But what if they had like the square root of 25? So if they had that symbol on there, square root of 25 would equal 5. So that would be a whole number. Also, if they had 9 divided by 3, don't think it would be up here because it's a fraction, because 9 divided by 3 would equal 3. So we need to convert all fractions and percents. But like I said, this is a little bit extra. They just want to know if you know the difference between the sets and the subsets. And of course, natural numbers are 1, 2, and so on. Over here for the irrational numbers, this is where you would have like pi. You would have the square root of 7. You You can't write that as a fraction. If you had a decimal that was negative 0.0125495, I mean, there's no pattern. It just keeps going on forever. That would be one as well. Those are just examples. They're not going to ask you which one is a whole number or a real number on the test. Let's see if we can go to the next slide. We did that one. We did that. And here's an example of the STAR test. So, which Venn diagram correctly represents a relationship between rational numbers and irrational numbers? Okay, well, let's eliminate our answers. So, let me change the pointer here. Do we recall, and I'm going to use this right here. I know it's very small, but you should be able to tell. Is the real number system list the rational numbers and the irrational numbers inside of it? No. They are two separate. One is over here, one is on the left, one is on the right. What about like this? Is it the same except for rational numbers are part of irrational numbers? No. How about here? You have the real number system and you have rational numbers and irrational numbers, but you also have some that are in both categories. Did we have any overlap in our notes? No. These are totally different. There's nothing that connects these two together. So therefore, hopefully you picked the answer C. That's it on real number system. Thank you for watching.